Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this DevOps.com program brought to you by Techstrong and Spot by NetApp. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. Over there, you'll also see a couple of other options. First one is the chat tab, and that's where we want you to have more general discussion with your fellow audience members. You can start off by letting us know maybe where you're tuning in or what role you play in your organization. You'll also notice that there's a polls tab and a handouts tab. So that polls tab, we're going to go ahead and launch a couple of polls throughout today's program. If you don't get a chance to answer them whenever they first pop up, they will remain open. So feel free to respond as you can. And if you press that handouts tab, you'll see there are quite a few resources there available for download. So grab those just for some complimentary materials for today's program. And as always, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around. So the title of our program today is Automating Compute Infrastructure to Accelerate Your Cloud Journey. And I'm joined by Jeremy Deshotel, Senior Solutions Architect at Spot by NetApp. Jeremy, thank you so much for being here with me. And I'd also like to send a big welcome introduction to Cash, our developer advocate in Doganese. So I'd like to welcome Jeremy and Cash to the program.
Thank you. Put Cash down. He's my DevOps evangelist. Hey everyone, how you doing today? I'm Jeremy Deshotel, Senior Solutions Architect here at Spot by NetApp. And today I'm going to go over an agenda. I've got a lot to go over with you today. The first thing we're going to discuss is where the current state of cloud adoption lies as of 2022. We're also going to discuss some of the biggest challenges, limitations, obstacles to a rapid adoption of the public cloud. We're going to discuss optimizing infrastructure, specifically around the various purchasing models that are available to you in the public cloud. Then we're going to talk about the philosophy of continuous optimization, which all of Spot's solutions have and embody. And then lastly, we'll open it up for a Q&A. So without further ado, as we all know, organizations are rushing to adopt the public cloud, whether it be for standardization across a skill set with engineers, whether it be due to high availability, fault tolerance, governance standards, or the ability to, as a young startup, have your costs scale in accordance with your growth. Companies are rushing to deploy more and more in the cloud every year. And most of them intend on or have already moved a majority of their workloads over. So as we can see in this infographic, many companies are either currently cloud native or within the next 2 to 3 years have an initiative to do so. So in terms of priorities within the public cloud, organizations are looking to invest in a number of improvements to the way they go about doing things. So one of the biggest ones is automation. This has surpassed cost management as the most sought after improvement to the current cloud infrastructure. Cost management, obviously a close second. Those costs can quickly, balloon out of control if not maintain proper governance over them. And then resource inventory and utilization. These things can be made better by automation and have a direct impact on the cost management aspect. But resource inventory utilization, minimizing idle resources and things of that nature. Now, what are some of the challenges here? Again, one of the biggest ones is cost concerns. Obviously, as opposed to running, your own data center where you own all the hardware, at first glance, adopting, resources in the public cloud can seem very expensive. Security concerns. And although the public clouds today are extremely secure, both in terms of physical security as well as data security, security concerns from misconfigurations, bad actors, things like that still plague organizations today. And then lastly, a lack of in-house skills. So with the public cloud being relatively new in the world of IT, it's become increasingly difficult as companies have rushed to the cloud to find applicable workforce that's trained, certified, and ready to ramp up quickly. So with that, I believe we have our first poll that we can throw up on the. There we go. So our first poll says, which of these is the biggest focus in your organization this year around cloud initiatives? Is it around automation, reducing costs, improving utilization and eliminating those idle resources, or something else? None of the above. So we'll give it a couple minutes for everyone to answer.
Jeremy, the results should be displayed on the screen.
Yes, I see them now. So it looks like it's actually in line with what the audience or the industry at large has also stated, which is automation being the main priority, followed closely by reducing costs, and then eliminating idle resources and improving overall utilization, which again has a direct impact on reducing those costs. So I'll move over to the next slide, and feel free to still answer the poll if you haven't gotten a chance to yet. So now I want to talk about optimizing infrastructure across different purchasing models. And so there's three major ways to purchase cloud compute today in the public cloud. The first of which really is what makes the public cloud so incredible, is the idea of on-demand infrastructure. The ability to instantly spin up resources to run your applications on, spin them down when they're no longer needed, and to only pay by the minute, by the second, by the hour for what you're actually consuming. The caveat here is this is the most expensive form of compute. The second, which is committed capacity, so things like reserved instances and savings plans, these offer decent discounts. It's similar to purchasing, making a purchase that's supposed to last for years and years, making a purchase of hardware for the data center. You're typically committing 1 to 3 years, so you lose a lot of that flexibility in exchange for that discount. However, for long running, stateful, monolithic applications, this is typically the best fit. And then lastly is the idea of excess capacity. So all three major US public cloud providers now offer spot instances. They've previously been known as preemptible in GCP or low priority VMs in Azure. But this is the concept of excess capacity, basically a fire sale. The cloud provider is offering the steepest discounts, 70, 80, 90%. However, at any point, if that capacity is no longer available and someone else is willing to pay that on demand or pay as you go price, those resources can be terminated from your environment with as little as a 30-second to 2-minute notification. So they're the most cost efficient, but they're also the most complex to implement effectively. And that's where we come into play. So let's take a look at this. The way spot VMs work is each cloud provider has a number of what we call spot markets. So this is the intersection of an instance size, an instance type, an operating system, and a particular region or zone or data center. And so for each one of these intersections, there's a separate market, a separate finite amount of compute that is offered at that steep discount. So, what if you were able to architect your applications in a way that they didn't really care much about the underlying infrastructure as long as there was enough resources for them to run successfully on? You could build a strategy to dynamically leverage this excess compute and with predictive analysis possibly run more stably than you would have otherwise done using native cloud tools. So that's where we come into play. If you look at most elastic applications today, now whether they're containerized or not doesn't really matter. But if we think in terms of auto scaling groups, machine instance groups, scale sets, if you will, typically we're going to only use one or two instance sizes or types. We might have a base level of reserved instances or savings plans to cover that base traffic. But then everything we scale up is typically going to be done with on demand, the most expensive form of compute. Compounding on that, the fact that we're only leveraging maybe a particular instance size ensures that we will be over provisioning with every scale up action. So we take a little bit of a different approach here at Spot. Think of this in a much more heterogeneous way, where you can have applications effectively, let's say in a Kubernetes cluster, where some workloads are very rigid and need to run on demand. Others are stateless in nature, run many replicas, and can easily be orchestrated and scheduled on Spot instances. And then maybe you also have some commitments that you've purchased and you want to ensure that those don't go to waste either. What if within one abstraction, within one scaling mechanism, you could leverage all three pricing models, but not only the three pricing models, but also every instance size and every instance type that's suitable for your workloads? This would obviously result in a much more granular approach to scaling, both from a cost and a performance standpoint. We'd be able to have a much more optimized way of deploying these applications. So let's talk about this philosophy, this idea of continuous optimization. We're all familiar with the little figure eight, the CI/CD, the software development lifecycle. Okay. But once those applications are deployed, once they're running in our production environment, what now? Things like right sizing, things like, adjusting scaling policies. In my previous role, that was something that was always on the to do list, but typically got deprioritized by security patches, by bug fixes, by new features that needed to be released. And therefore, significant amounts of money were wasted. We believe that the idea of continuous optimization, these right sizing of resources, these eliminating of idle resources, these ensuring that you're always running on the most efficient from a performant and cost standpoint form of compute, it should be continuous. It shouldn't be something that is looked at once a quarter, annually, once a month, looked at by dozens of spreadsheets to then make a decision. It's something that should be automated, right? And it should require as little human intervention as possible. And so that's where we talk about day two operations. So we're going to talk about day two Kubernetes operations, really more broadly talking about microservices architecture, which is a significant push for most organizations today, if they've not already adopted it. But what does day two Kubernetes operations mean? Day zero is designing a microservices architecture, picking a platform, whether that be picking your cloud provider, picking your control plane, doing things like infrastructure as code, integrating CI/CD pipelines, automated builds, right? Day one is configuring those applications, their resource sizes, and deploying them. But day two Kubernetes operations, day two operations in the public cloud is really where operational excellence and cost efficiency are going to come into play. This is making decisions around scaling, making decisions around high availability and performance, looking at visibility into costing and management of costing. So day two is here. Now, this is actually a stat that's over a year old. The latest results were pulled at the end of 2020. But 92% of companies today are running containers in some form in their production environment. So, with that being said, I'd like to throw up our second poll. What level of adoption has your organization achieved in terms of a microservices or container based architecture? Are you fully containerized? Do you have some workloads there and you're in the process of migrating more over or moving greenfield applications there? Do you have maybe just a few business units testing it out? Or do you have no intention of leveraging it whatsoever? Give it a few more seconds for anyone else to answer. And this is typically what we see. Most companies have a significant portion of their applications migrated over. It's very rare that we see a large enterprise having fully bought into and migrated everything over. But most companies at least have some testing or development workloads running in a microservices architecture, and they're either actively testing or actively planning on moving more over. So we can go to the next slide. And again, feel free to answer it if you haven't already. So again, day two is here. And so 92% of companies are running containers in production. It's probably a little bit higher today, but roughly 70% are doing so with over 50 nodes, meaning significant applications, more so than just a sandbox or testing environment. So why is this idea of day two operations a problem for DevOps engineers? Uh, Kubernetes says infrastructure. That's not my problem. I'm designed to scale applications, not infrastructure. Cost becomes extremely difficult to trace whenever you have many different applications and at times different applications for different teams running on the same infrastructure. Outnumbered, there's typically very few DevOps or cloud or infrastructure engineers as opposed to developers. And that also bleeds into, overhead of labor. Infrastructure management can be very complex and time consuming if you haven't already prioritized the idea of automation. So with Kubernetes, we have two layers of scaling. There's the actual application or pod scaling, which is going to be handled by Kubernetes. But then again, we have the infrastructure scaling. And this is something that natively Kubernetes does not handle. the instance type and size selection. That is something we have to manage on our own. So the problem there is meeting the application's demands while minimizing idle resources. It's easy to meet the application's demands if you're running extremely over provisioned. And that's what we typically see today. But meeting your capacity needs while also eliminating waste is something that has been proven very complex. So, what I'd like to present is a slightly different approach to scaling, the idea of container driven scaling, the idea of no longer thinking about nodes and infrastructure and hard coding those requirements. Well, what does that look like? What would a serverless or nodeless experience mean? So it means no manual management of the underlying infrastructure. It means scaling by request based on real time requirements. Well, what is that? That means when a deployment increases the replica count and now you have a pending pod, it needs to be scheduled. And scaling based on the actual resource requirements of that pod rather than by some default number of instances based on some arbitrary metric following some cooldown. Whether we need one pod or 1,000, whether we need one node or 100, we should be able to scale it instantly based on the application's needs. Following with the public cloud, utility billing, paying only for what we use and eliminating waste. Well, other than a base level of traffic, that requires getting away from the idea of just using savings plans and reserved instances. Scale to zero. We should be completely dynamic. We shouldn't need infrastructure running where no applications are running on it. And fast scaling, not waiting for thresholds of utilization, but scaling based on the container needs immediately. So, how are we going to achieve that? Well, let's look at that ideal, what it looks like when these containers are first class citizens. So, things like instance size, type, and pricing model is determined based on the pod definition file, the YAML file that you configure the spec for the pod. We should be able to, based on the memory and CPU requests, scale an appropriately sized node. If you're requiring a GPU driver, we should naturally spin up a GPU based instance with that driver. If you have a single replica or a simple label denoting that a particular workload needs to be ran on an on demand node, we should be able to react to that as well. So this should be able to be done dynamically rather than managing dozens or hundreds of node groups or instance groups, different configurations where we're hard coding infrastructure requirements into each one. Because every time a developer deploys a new application, a new node group would have to be created. We'd have to identify the resource demands of that application, pick instance sizes that fall within that. And only then will Kubernetes be able to scale and schedule those pods on those nodes. So, this is what it would look like in an ideal world. So, let's look at the numbers. So, again, the idea of continuous optimization isn't only the idea of initially provisioning the appropriate infrastructure, but also continually looking for opportunities to reduce the footprint of a cluster and increase overall utilization. So in this example, we've got a deployment where we've got one pod. It's requesting 6.5 gigs of memory, and it's requesting 1.5 cores. We throw it on an M5 large, and we're spending just under 10 cents per pod per hour. Now, if that deployment scales up and we need another pod, we could put both of them on an XL, or we could put each one on a large. we'd still have that same 81 and 75% utilization and still be spending about 10 cents per pod. Well, let's say we look at a 2XL. Now, you would think that we could fit 4, but because of that extra space with each pod, even though this is twice as expensive as the XL being twice as expensive as the large, we actually can fit a 5th pod here, jumping utilization or allocation up to 98% of our memory and 93% of our CPU. This alone results in a double-digit percent decrease in our average cost per pod. So Spot's Ocean solution, in addition to orchestrating reliably on Spot instances, also is always looking to have your cluster run the same amount of workloads on fewer infrastructure. Well, let's look at a different example. Let's look at 2 different instance types. So let's say we have that same pod. We're requesting 1.8 cores and 6.5 gigs of memory. And we have our auto scaling group configured to use C5s, right? We might be scaling our cluster auto scaler, might be scaling based off of CPU utilization. And so we're using compute based nodes. Well, this pod comes in at about 17 cents per hour. Yet, what if, based on the resource requests of the pod, what if our autoscaler was intelligent enough to say, we could actually put that on a general purpose instance based on this ratio of memory to CPU requests, thereby maintaining the same memory utilization, but literally doubling our CPU utilization and resulting in about a 40% lower cost per pod, 43% to be specific. So this concept of automated bin packing in real time is just one of the many layers of optimization that Spot's Ocean brings to the table. So container-driven infrastructure auto-scaling is that concept I want you to think about, and ensuring that your applications always have the right amount of resources to run on without having excess waste, and ensuring that the most suitable instance type and size to meet the application's requirements is dynamically spun up. Then maximizing resource utilization by continuing to look at the current configuration of the cluster and identifying opportunities to improve. Cost management and showback, tracking where these costs are, tracking on a service by service or deployment by deployment basis where these costs are arising, from networking to compute to storage, and being able to allocate those costs back to their respective business units. And lastly, automatic right sizing, measuring real-time utilization of these resources by the applications, and then when they're not properly sized, giving you recommendations so that way you can adjust the sizing of them to improve the efficiency of bin packing. Developers typically will build an application, containerize it, say this much CPU and memory should be more than enough. And very rarely is that in a short period of time looked at once it's running in production and then adjustments made. And so right sizing should be that third pillar of optimization, where we're able to significantly increase our bin packing potential by ensuring our applications are sized to their actual needs. So I'm going to stop there. We're going to open up the Q&A section for any technical questions that you might have about any of the concepts that we went over today. If you would like to learn more, you can visit our website at spot.io. If you would like to set up an in-depth presentation, maybe a technical deep dive with myself or one of our other solution architects, you can email me there at jeremy.desatel@netapp.com. And yeah, so let's open up the Q&A section.
So I'm just taking a look around and seeing what kind of questions we've got so far. But let's start with this softball. How do I get started?
Yeah, great question. So if you go to spot.io, now the ideal way, the salesman in me would say, email me and I'll get you started. But if you go to spot.io, you can actually register for a free account. And with that free account, you can actually manage up to 20 nodes free of charge. You don't need to enter a credit card or anything. Um, Once you do that, however, you might want to reach out for a technical demo, as well as if you look in our documentation page, docs.spot.io, you can find all the information you need to connect your cloud provider. So it involves creating a free account on spot.io, connecting your cloud provider. We support GCP, AWS, as well as Azure, and then importing a workload. Great question.
So is there a way that we can try this out before making any commitment? Maybe a POV or POC?
Yeah, absolutely. So again, creating a free account and connecting your cloud provider, you can manage up to 20 nodes for free. Now, if you'd like to do an in-depth, extended proof of value, proof of concept stage, that's where I would highly recommend reaching out to our sales team and getting that set up. Because typically, if your company wants to do a proof of concept, I'll go in on the back end, bump up your permissions temporarily to that of a full-fledged paying customer, and then really let you test some of your workloads, maybe a dev or a test cluster, run it for a few weeks, and then get the data points you need to make an intelligent decision.
So what kind of support should a Spot user expect?
So, in terms of support, this is actually one of my favorite features of our platform. We offer 24/7 chat support, and that chat support comes along with a 2-minute SLA. Now, we're not very happy with that, and our average response time is actually hovering around 30 seconds. So within the UI or console, you can click a big blue button on the right-hand corner that says chat, and any questions about configuration, infrastructure as code, what's going on with your environment, how to configure your scaling for the most efficient manner, within 2 minutes contractually, or 30 seconds on average, you can have an answer. Good question.
So this participant asks, or rather says, we've tried to use Spot instances with our applications. How do you prevent application downtime when an interruption occurs? And do you have any guarantee or SLA with using Spot instances?
So that's a great question. I'm going to answer this at a very high level. I want to stay conceptually or philosophy focused and not just drill down too much on products. But the way it works is, again, in the cloud providers, you typically will get a 30-second to 2-minute notification. Other than the quickest spinning up, most stateless, lightweight applications, that's just not enough time to react. So our platform is able to detect when terminations are likely much further in advance. And rather than wait on a termination notification, when we identify that a termination is likely in the coming hours, we will proactively identify a healthier spot market, get that instance spun up, get it added to your load balancer, added to your cluster, gracefully drain the connections from the instance to be terminated long before you would ever get that notification. 85% of the time, we're actually replacing spot instances over an hour before that market has seen any interruptions whatsoever. In terms of an SLA, we actually offer an SLA around our uptime and therefore our ability to meet your capacity needs. Because in the event that there is no spot capacity whatsoever, we automatically fall back to on demand or pay as you go pricing, spin those up to make sure you always have enough infrastructure while continuing to monitor the health of the markets. And as soon as that spot capacity becomes available again, capturing those spot instances, spinning them up, and then doing the same thing in reverse to ensure that you're always running the lowest cost form of compute available.
So we've got another spot instances question. Are the spot instances limited as just Kubernetes related or app dev related, or can they be used in a more user-like virtual environment or virtual machine environment as well, i.e. Azure dedicated user virtual machine?
Absolutely, great question. So I'm assuming you're referring to outside of just containerized applications. Like if we're just talking about maybe a scale set in Azure behind a load balancer or something like that. What I say is if the application is elastic in nature, if it's stateless, if it can, even if it can just handle, even if it's a single VM, but it can handle a restart, it can be orchestrated on spot instances reliably and stably using our platform. And so that would be our solution called Elastigroup. And so it's for any stateless, any elastic application that is not containerized.
Perfect. So I am going to put this next question up on the screen and read it out loud since it is a little bit longer. So how many nodes in a cluster is what the cloud provider charge? Do they limit how many pods can go in a node? Clusters are usually ordered with a minimum number of nodes. Then how a pod-driven autoscaling can help reduce nodes cost.
Okay. Yeah. So a lot to unpack there. Typically, we recommend a minimum number of nodes of 0 in terms of your data plane. Okay. Obviously, your control plane, your master nodes, if you will, need to always be up. But in terms of your data plane, that should be able to scale down to 0 if you were to have no applications running. Or is the amount of pods that can go on a node limited? Great question. The answer, like so many things in life, is it depends. For instance, in Amazon's EKS, based on the instance size and instance type, there is a fixed maximum number of pods per node. And so you can run into the issue if you have very small, lightweight pods where you're not running a very high utilization, yet you're still using the maximum number of pods. That's rare, but that is something that is limited by the cloud provider and control plane. But for most customers running production applications, it's not an issue. You'll run out of resources on the node before you'll hit the maximum number of pods on said node.
So let me ask you this question. What is the end goal with automating compute infrastructure? What are we looking to attain here?
Yeah, what we're looking to attain, if we think about the concept of DevOps, the ability for operations or security personnel to kind of let go of the reins and have the developers deploy applications at will while still maintaining a handle around costs, governance, security, the ability to roll back, things of that nature. And so that tug of war has been going on for quite some time. And the end goal of this would be to have an automated and dynamic approach to infrastructure provisioning, scaling, and continuous optimization that results in much more time being given back to the DevOps personnel. I know that this tool in one of my previous roles would have probably freed up about an hour, hour and a half of my time on a daily basis. And so freeing up that time so DevOps infrastructure, cloud engineers can spend that on innovating and not configuring, managing, overseeing, troubleshooting, debugging, but can actually spend that time innovating and feeling comfortable to give the reins over to the developers to allow them to deploy their applications at will, knowing that resources won't be wasted, scaling will happen in an automated fashion without any human intervention, and the correct provisioning of resources following all governance constraints will be applied.
So during today's program, you did cover a couple of barriers to automating, but what would you say is going to be the biggest and baddest barrier to overcome, in your opinion?
Yeah. So, purely my opinion, but I would say one of the biggest burdens is going to be the personnel, the trained personnel, and the bandwidth of said personnel to be able to implement those automations. That's one of the great things about what we do is you can take an existing running infrastructure, whether that be a web app behind a load balancer in an auto scaling group or scale set, whether it be a Kubernetes cluster running on EKS, whether it be an Amazon ECS cluster, or maybe your CI/CD pipeline, your Jenkins build server, or your GitLab runners. We can import those in a matter of minutes, automatically generate infrastructure as code templates, and within 5 minutes, leveraging best practices, infrastructure as code, you can deploy these applications in a much more dynamic approach and while saving a lot of money. And so that's the solution to that biggest barrier that I said. But in terms of the barrier across organizations, what we're seeing today is just companies don't have enough people, and those people don't have enough time.
Well, we can only hope to automate and help relieve some of that stress. So I'm not really seeing any. Oh, here. Okay, we do have two more questions.
Sure.
Someone says, "Is there any sort of commitment, and what can you explain the cost?" So
Yeah, great question. So there's no commitment. What we do, the solutions we offer are pay as you go, same way you pay for compute in the cloud today. And in terms of the cost, we have this is honestly one of the main reasons I took this role about 2.5 going on 3 years ago. We only charge as a percentage of the savings that we deliver after we've already delivered it to you. So if you go above and beyond the free trial, or you actually become a customer, at the end of each month you will receive an invoice for how much money has been saved, and then you just kick a percentage of that back to us. So I like to say we don't make a dime until we've already put $1 back in your pocket.
all right, and this next question is kind of in the same vein, but we'll just go ahead and address it. Do you have a way out after the trial period is done? They also said, I don't see any delete for cloud formation template.
Okay, great question. So there's not really a way out that's needed, as you don't have to enter any payment information whatsoever to begin that trial period. With just an email and a password, you can set up an account and test out the platform. And whether that be you doing it on your own or alongside a solutions architect like myself to do a defined proof of concept period, still no billing or payment information is required. And in terms of delete CloudFormation template, I'm assuming you're referring to once you've connected your account in an automated fashion, we provide a CloudFormation template to connect your account. Within the cloud provider itself, within AWS for CloudFormation, you can actually just delete that stack. And if you were to delete that stack, that role would be deleted. We'd no longer have your Spot account would no longer have access to your AWS account, and that would be it. Great question.
Awesome. So I'm not seeing any more questions in the queue at this moment. So I'm just going to
Sure.
buy us some time and announce that today's session was recorded. Following this program, you'll receive an email with a link to access the recording on demand, or you can rewatch it on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. And I'll also give away our 4 $25 Amazon gift cards. Our winners are Kapil K, Jed R, Xing L, and Susan W. So to our 4 winners, congratulations. Keep an eye on your inbox to claim those gift cards, but if you do not happen to see that email, please do check your spam folder. All right, Jeremy, not seeing any more questions. I do want to give you the opportunity to leave our audience with any closing remarks, anything you'd really like them to take away before we close out.
Yeah. Just in closing, the idea of continuous optimization is really the philosophy or the paradigm shift that I think sometimes seems like a far-fetched or fantasy, but by leveraging tools that are out there available to you today, by approaching things with a DevOps first mentality, you can achieve much more automation, much lower costs, all while reducing that management overhead and time commitment on your behalf. So just really want to nail that home. And whether you reach out or not, whether you create a free account or not, always striving for that dynamic approach to cloud infrastructure.
Perfect. Well, Jeremy, thank you so much for spending the last hour with me. It was really nice getting to know you before the webinar, but it's always better to hear what you're here for. And I definitely am taking away a lot from this today. So thank you so much for all the work that goes into putting together this presentation.
Absolutely. Thanks for having me.
Of course. So Jeremy, thank you. I'd like to give a huge shout out to Spot by NetApp for sponsoring today's program, and to everyone who joined us, who participated in our chat, sent in questions, participated in our polls, or downloaded our handouts. Thank you so much for being here. We really value your time, and we also really, really value your feedback. So as soon as we close out, a survey will pop up on your screens. We'd really appreciate you filling that out for us. Let us know what we could do better. Let us know how we did great today. Just let us know your thoughts. Otherwise, we do hope to see everyone at an upcoming Techstrong learning program. Have a great rest of your day, everyone. And Jeremy, thank you once more.
Thank you.